Currently, there is an object located approximately 350 million kilometers from Earth, moving toward the Sun, which is defying everything we know about the laws of physics. It's exhibiting behavior that scientists can't explain. Its tail is not facing away from the Sun, as is typical with comets, but instead, it's pointing directly towards it. This is a clear violation of the basic principles of comet dynamics. Furthermore, the object is ejecting a material composition that shouldn't be possible: nickel without any iron. A Harvard scientist recently calculated that there's only a 0.2% chance that its trajectory could have occurred naturally. This object is the third interstellar visitor ever detected, named 3IATLAS. Over the coming days, it will either confirm its status as a comet or challenge everything we understand about these celestial bodies. This anomaly has captivated scientists, leaving many to ask whether it is truly a comet or something entirely different, possibly even artificial in origin. The issue begins with its tail. When astronomers at the Twin Telescope in the Canary Islands observed it in August, they discovered a gas and dust trail, approximately 3.7 miles long, which was not following the usual outward trajectory of comets, but instead was pointing directly at the Sun. For context, every comet ever observed has a tail that is driven away from the Sun by solar wind and radiation pressure. The fact that this object's tail is heading toward the Sun is what scientists are calling an anti-tail. It's an anomaly that completely contradicts the fundamental physics of comet behavior. One of the few scientists openly addressing these concerns is Professor Avi Loeb from Harvard. While most comet experts are dismissing this detail as insignificant, Loeb believes that the evidence points towards something far more complex. He argues that this anti-tail, coupled with the nickel without iron, the strange trajectory, and other anomalies, suggests that this object may not be a typical comet at all. Loeb is willing to go as far as to say that the combination of these peculiarities could be more consistent with technology than with natural processes. Despite these claims, NASA continues to classify 3IATLAS as a natural comet. They've analyzed the same data, spectroscopy, chemical composition, trajectory, and their conclusion is that it's an interstellar comet, albeit a highly unusual one. The real question, however, is whether this interpretation is being defaulted to because it fits neatly into existing scientific models, and the alternative might disrupt too many established theories. Historically, scientific institutions have resisted paradigm shifts. It's how science operates, demanding overwhelming evidence before accepting any revolutionary ideas. This caution helps prevent jumping to conclusions, but it also means that genuinely anomalous discoveries can be easily categorized as normal, simply because the scientific community isn't ready to confront the uncomfortable possibility that the universe is far more complex than we previously thought. This is why the scientific community is so divided over 3IATLAS. If it turns out to be a comet, the anomalies will be explained away as rare but natural occurrences. But if it survives its close pass by the Sun without fragmenting, something that almost always happens to comets at such a close distance, then the questions surrounding its origins will only grow stronger, and the conversation will have to change. As we wait for 3IATLAS to make its closest approach to the Sun, the situation grows more urgent. Observatories are watching closely, and if this object fragments, then the comet theory will likely remain intact. But if it survives intact, then the discussion will shift dramatically. Could it be something else entirely? Something artificial? The next few weeks will be critical. Whatever happens, this object is forcing scientists to rethink their understanding of comets, space physics, and perhaps even the possibility of extraterrestrial technology. We may be on the verge of a discovery that forces us to reconsider everything we thought we knew about the universe. But until the data is in, the mystery remains, compelling, puzzling, and intriguing in equal measure. As the object, 3IATLAS, continues its journey through our solar system, it presents an array of features that cannot be ignored. Every new piece of data seems to raise further questions. The stream of anomalies is growing, and astronomers are left trying to piece together a coherent explanation. From its peculiar tail to its unexpected chemical composition, this interstellar object has scientists gripped, and as it approaches the Sun, the key tests will unfold. But what happens next could change everything. One of the most puzzling aspects of 3IATLAS is the outgassing, its emission of water vapor. When the Swift telescope turned its instruments toward the object in October, they detected something unexpected, a massive release of water vapor around 40 kilograms per second. To put that in perspective, imagine 41-liter bottles of water evaporating into space every single second. This represents a constant stream of vapor, which at first glance seems unremarkable, but the problem lies in the object's location. At the time of detection, 3IATLAS was located about 3 astronomical units, AU, away from the Sun, a distance roughly equal to that of the asteroid belt. At that distance, the Sun's radiation is only about 11% as powerful as it is at Earth's orbit. For comparison, comets typically don't start producing significant amounts of water vapor until they're much closer to the Sun, around 1.5 AU. 3IATLAS, however, is already spewing out an extraordinary amount of water at a distance where it should still be frozen solid. The thermal energy from the Sun simply shouldn't be enough to cause this much activity. So what's powering this outgassing? Some researchers have speculated that there might be some form of subsurface heat, perhaps from the radioactive decay of elements within the object. However, this explanation presents its own set of problems. Radioactive decay, even from elements with long half-lives, doesn't generate enough heat to explain the massive amount of vapor being released. After billions of years, any short-lived isotopes within the object would have decayed long ago, leaving behind very little residual heat. Another theory suggests that 3IATLAS might contain highly volatile materials, substances that vaporize at extremely low temperatures. Perhaps the object harbors exotic ices, compounds not typically found in our solar system, but still, spectroscopic analysis hasn't turned up anything unusual enough to justify this theory. The object's composition, though strange in some respects, such as its high CO2 to water ratio, does not show signs of the exotic volatile compounds that could explain the outgassing. This is where the scientific community begins to diverge. The idea that 3IATLAS could be spewing water vapor for reasons that don't align with the physics of typical comets challenges everything astronomers thought they knew. What's even more baffling is that it's happening at a distance where the energy from the Sun should be minimal, and yet the object is behaving as if it's much closer to the Sun, much more active than it should be. The gap in understanding only deepens when the object's behavior is compared to that of typical comets. 3IATLAS does not fit the standard model. But what's most perplexing is how we're seeing these anomalies. Some scientists believe that there could be a deeper hidden mechanism at play, one that we are unable to fully understand. This is where things start to become unsettling. The standard models simply don't work in this case. If 3IATLAS is indeed a comet, as NASA insists, then the observed outgassing should not be happening. Moreover, it's not just water vapor that's raising eyebrows. The object is also emitting nickel without any iron, which is another chemical anomaly. This is a compound that should not naturally occur in the quantities being observed. One of the key pieces of data that has scientists puzzled is the detection of nickel tetracarbonyl, an industrial chemical used in refining processes. It's not a substance you'd expect to find in the natural world, much less in a comet. The only place nickel tetracarbonyl is typically found is in highly controlled industrial environments, which further leads to the possibility that something artificial is at play. Nickel tetracarbonyl forms when nickel reacts with carbon monoxide at very specific temperatures and pressures, conditions that don't naturally occur in space. However, if 3IATLAS is somehow able to produce this compound, it suggests there's an internal mechanism within the object that could be concentrating and isolating nickel. It raises the possibility that the object has some kind of refinery process happening within it, which is entirely outside the realm of known comet behavior. As researchers grapple with this baffling data, there's a silence coming from the mainstream scientific community. Unlike previous interstellar objects like Oumuamua or Borisov, 3IATLAS has not sparked widespread public excitement. While data is still being collected, there is an almost eerie reluctance to openly discuss the unusual aspects of this object. Perhaps this silence is due to the sheer complexity of the situation. These anomalies don't fit the established models, and scientists are reluctant to entertain the possibility that the object could be artificial. But for some researchers, such as Professor Avi Low, the lack of open discussion is troubling. He has criticized the mainstream community for downplaying or ignoring the anomalies in favor of sticking with the safe comet explanation. Low argues that this reluctance to entertain new possibilities might prevent us from recognizing the object for what it might truly be. If 3IATLAS is not a comet, then it might represent something entirely new, something far more extraordinary than any celestial body we've encountered before. This isn't just about challenging scientific norms. It's about asking questions that we, as a species, may not be ready to answer. Low has put his reputation on the line, arguing that the evidence points to the possibility of an artificial origin. Whether or not he is correct, his willingness to pursue this line of inquiry is helping to shift the conversation, opening up new avenues for research and debate. For now, though, 3IATLAS continues to captivate the scientific community, and as the object moves closer to the Sun, the next phase of observation will be crucial in determining whether we are witnessing the death of a comet or the emergence of something entirely new. In the coming weeks, scientists around the world will be analyzing every new piece of data that comes in. The question remains, will 3IATLAS behave like a comet, fragmenting and disintegrating as it gets closer to the Sun? Or will it survive, defying expectations and offering us a glimpse into a far more mysterious reality than we ever anticipated? The upcoming close approach will be a critical test, one that could either confirm or completely overturn our understanding of what this object is and where it came from. For now, all we can do is watch, wait, and hope that this mysterious visitor reveals its secrets. As 3I-ATLAS nears its closest approach to the Sun, the anticipation within the scientific community has reached a fever pitch. The object is behaving in ways that challenge the established laws of physics, and the answers we'll uncover in the coming weeks could either resolve these mysteries or deepen them further. The critical point is fast approaching, and astronomers are prepared to analyze whatever happens next. One of the most intriguing aspects of 3I-ATLAS, besides its unexpected outgassing and the nickel tetracarbonyl anomaly, is its shape. While most comets and asteroids are irregular in shape, 3I-ATLAS is reported to have a cylindrical form, which is incredibly unusual for a celestial object of its type. Most small bodies in space, like asteroids, are lumpy and irregular due to random accretion. Larger objects may become spherical due to gravity's influence, but small bodies typically retain more jagged forms. A cylindrical shape, however, suggests a level of precision and structure that we don't typically associate with natural processes. Cylindrical shapes are often associated with man-made objects, such as spacecraft or rockets. This has led some scientists, including Lowe, to propose the possibility that 3I-ATLAS could be artificial. The geometry of a cylinder could be ideal for certain engineering purposes, such as maximizing internal volume while minimizing surface area, which makes it an efficient design for space travel. If the cylindrical shape of 3I-ATLAS is confirmed by further observations, it could become one of the strongest pieces of evidence for an artificial origin. However, shape determination for distant objects is notoriously difficult, particularly when they are as faint and distant as 3I-ATLAS. Factors such as rotation, lighting, and perspective can dramatically alter our perception of an object's true shape. To get a more definitive answer, astronomers will need higher resolution images, ideally from spacecraft like the European Space Agency's JUICE mission, which will be positioned in a unique way to observe 3I-ATLAS from an angle that ground-based telescopes cannot match. These observations, along with those from other space-based observatories, could provide crucial clues about the object's true nature. While the cylindrical shape could be a sign of artificial design, it's important to acknowledge that natural processes might also account for this form. For instance, rotational dynamics or crystallization processes in a comet's core could stretch the object along one axis, forming a shape that could appear cylindrical. Yet, as scientists continue to analyze the data, it remains clear that 3I-ATLAS is displaying far more unusual features than we would expect from a natural object. The possibility that this object could be artificial leads us to another crucial question. If it is a probe or a spacecraft, how would it function? If 3I-ATLAS is an advanced piece of technology, it could potentially be carrying out some kind of mission. It could be a relic sent from an alien civilization, or perhaps even an autonomous probe designed to explore other star systems. If this object is in fact a probe, its close pass through our solar system could provide valuable data about the planets, moons, and other bodies within our system. Data that could be gathered without our knowledge, unless the object is actively seeking to reveal itself. This brings us back to the trajectory of 3I-ATLAS. The object entered the solar system on a path that has a 0.2% probability of occurring naturally. It's approaching the Sun in such a way that it could potentially use the Sun's gravity to adjust its speed and trajectory, a technique known as gravitational assist. This maneuver would be familiar to any civilization capable of interstellar travel. The precise alignment of 3I-ATLAS's trajectory with the Sun could indicate intelligent navigation, purposeful course corrections, rather than a random flight path. If 3I-ATLAS is truly a probe, the fact that it has managed to navigate the solar system with such precision suggests that it is not a passive object. It may have been designed with a mission in mind, and its approach to our Sun could be part of that mission. Scientists are watching carefully for any signs of intentional behavior. Could the object change its course, accelerate, or decelerate in ways that we can't explain by gravitational forces alone? Small, controlled maneuvers might be detectable in the data. The velocity anomalies seen in the object's movement might be the first signs of an active propulsion system. The timing of 3I-ATLAS's approach further deepens the mystery. Its closest pass to the Sun will occur on October 29th. This is a critical moment because traditionally, this is when comets fragment. As the object gets closer to the Sun, it will be subjected to increasing thermal stress. Cometary nuclei, typically made of ice and dust, can vaporize and break apart when they pass too close to the Sun. If 3I-ATLAS survives this phase without fragmenting, it will be a strong indication that the object is not a typical comet. Instead, it could be something far more resilient, potentially even artificial. For astronomers and researchers, this date represents a crossroads. If the object fragments, it will fit the expected behavior of a comet, and scientists will likely offer explanations to account for its unusual features. But if it doesn't fragment, if it remains intact, continuing its trajectory without breaking apart, then the idea of an artificial object will become harder to dismiss. Such an outcome could suggest that this object is far more than a natural phenomenon, and the implications of that discovery would be profound. Another crucial piece of this puzzle is the object's apparent evasive behavior. While 3I-ATLAS has been observed passing by planets like Venus, Jupiter, and Mars, it has remained largely undetected from Earth. This level of stealth raises even more questions. Could 3I-ATLAS be avoiding detection intentionally? Is it actively hiding its presence, perhaps because it's aware of our observational capabilities? The object's ability to pass through the solar system largely unnoticed hints at an advanced understanding of observational limitations, something we would expect from a piece of technology designed by an intelligent civilization. As 3I-ATLAS nears its closest approach, every observation is being carefully analyzed for any signs of intentional activity. The expectation is that the object will fragment as it gets closer to the Sun, and if it does, it will be classified as a comet, albeit an extraordinary one. But if it survives intact, it could force the scientific community to confront the possibility that we are looking at something far more extraordinary than a comet. For now, the research continues, and the mystery deepens. The next few weeks will be crucial in determining whether 3I-ATLAS is truly a comet, or whether we are witnessing the first signs of a technology from another star system, an interstellar probe sent from a distant civilization to study our solar system. The answer could redefine our place in the universe and force humanity to confront the reality that we are not alone. Whatever the truth, the discovery of 3IATLAS has already begun to shake the foundations of what we know about space and the possibilities that lie beyond. As the countdown to October 29th continues, the scientific community is holding its collective breath. The moment of closest approach to the Sun is now just days away, and all eyes are on 3IATLAS. Will it fragment as expected for typical comets, or will it defy these expectations and remain intact, continuing its trajectory in ways that would challenge our understanding of interstellar objects? Every piece of data is being analyzed, and as more information comes in, the complexities surrounding 3IATLAS only seem to deepen. One of the most compelling aspects of this object's behavior is the apparent contradiction between its rapid movement and the usual expectations for comets at similar distances from the Sun. Comets are generally slow-moving bodies, particularly when they are far from the Sun. Their high speeds are typically a result of the gravitational interactions they undergo as they move closer to the Sun. Yet, 3IATLAS has displayed a consistent high velocity that doesn't entirely align with the expected gravitational effects. Moreover, there's something else about the velocity of 3IATLAS that hasn't been fully addressed: subtle variations in its speed. As it travels through the solar system, scientists have observed small changes in its velocity that don't fully match predictions based on gravitational forces. These are minor accelerations and decelerations, variations so small they are within the margins of error of most models. But these anomalies are there, and they've prompted speculation about their cause. The most commonly accepted explanation for such variations in velocity is the so-called rocket effect, a phenomenon caused by outgassing. When a comet ejects material, the ejected gas and dust can provide a small amount of thrust, propelling the object in the opposite direction. This is a well-understood effect in cometary science. However, in the case of 3IATLAS, the outgassing isn't behaving as expected. If the object's jets are directional or asymmetric, if material is being ejected from specific locations, it could suggest something more structured inside the object, perhaps an internal mechanism actively controlling the direction and nature of the outgassing. If that's the case, it would be a strong indication of something other than a natural object, perhaps an artificial one built with specific mechanisms to control its trajectory. Such controlled movement wouldn't be an obvious feature of a comet, whose outgassing is typically more random. The fact that these minor velocity changes have been detected at all, in combination with all the other anomalies, makes it harder to ignore the possibility that 3IATLAS is not simply a cosmic wanderer, but a highly engineered object. Even more intriguing is the spectral analysis of the object. The spectroscopic data collected so far has revealed a highly unusual chemical signature. As mentioned earlier, 3IATLAS is emitting nickel without iron, which is highly irregular. It's not just the presence of nickel, but its purity that has scientists puzzled. Nickel is usually found in nature bound up with iron, but in this case, it's almost pure. The presence of nickel tetracarbonyl, a compound used in industrial settings, raises further questions. Such a compound is not something one would expect to find in a comet, and its presence points to the possibility of complex artificial processes inside the object. Another highly peculiar aspect of the chemical composition of 3IATLAS is its carbon dioxide to water ratio, which is 8 times higher than what we typically see in solar system comets. This could suggest that the object didn't form in the same type of environment as most comets in our solar system. It might point to a very different origin, one in a star system where carbon and oxygen were far more abundant than hydrogen, which is the case for many older, metal-rich stars. Alternatively, this could be another clue that 3I-ATLAS formed under very different conditions, perhaps around a star with a different chemical makeup than our own. If 3I-ATLAS did form in a star system where carbon and oxygen dominated, it could be telling us a great deal about the diversity of planetary systems across the galaxy. This notion could challenge the assumption that our solar system's formation processes are typical of all star systems. 3I-ATLAS might be providing us with a unique glimpse into a part of the galaxy that's entirely different from our own, an insight into the diversity of chemical environments where planets and comets are born. All of these anomalies, its unusual trajectory, the odd outgassing patterns, the presence of industrial chemicals, and the strange composition are beginning to form a compelling pattern. Whether we're looking at an extremely rare natural phenomenon or something altogether artificial, the data is suggesting that we may be dealing with an object far more unusual than any comet we've ever encountered. It might not be a comet at all. It could be something from another civilization, something engineered to travel across the galaxy for reasons we can't yet understand. As 3I-ATLAS continues its journey through the solar system, every observation is being scrutinized. Researchers are desperately trying to determine whether the object will break apart as it approaches the Sun, or whether it will survive intact, potentially offering more clues as to its true nature. As we've seen with previous interstellar objects, such as Oumuamua, the excitement surrounding these mysterious visitors from beyond the solar system is palpable. But unlike Oumuamua, which was quickly observed and then left the solar system with little time for further analysis, 3I-ATLAS has presented scientists with a rare opportunity to study an interstellar object in great detail before it disappears into the vastness of space. This opportunity could be a game changer for science. If 3I-ATLAS survives perihelion and continues on its course without fragmenting, it would force scientists to reconsider everything they know about comets, chemistry, and the possibility of extraterrestrial technology. If the object behaves in ways that we can't explain using natural models, we might have to entertain the possibility that it's not a comet at all. Instead, we could be looking at a piece of technology, an interstellar probe sent from a distant civilization that has crossed the vast distances of space to observe our solar system. And this is where the stakes become even higher. If 3I-ATLAS turns out to be artificial, it would represent humanity's first confirmed encounter with a piece of alien technology. The implications of such a discovery are profound. It would not only confirm that we are not alone in the universe, but also open up a floodgate of questions. Who built it? When and why? What does this mean for the future of space exploration and the search for extraterrestrial life? This discovery could also shift the entire framework of our understanding of the universe. If this object is indeed artificial, it would suggest that intelligent civilizations exist far beyond Earth, possibly billions of years more advanced than we are. Such a revelation would have far-reaching effects on everything from philosophy to politics. the concept of intelligent extraterrestrial life would no longer be a subject of speculation, but a fact of life, one that could change the way we view our place in the cosmos. For now, though, we wait. The next few weeks will be critical in determining whether 3IATLAS is truly a comet, an anomaly, or something far more extraordinary. Whatever the outcome, this object has already forced us to confront the possibility that the universe is much stranger and more mysterious than we could have ever imagined. As we approach the pivotal moment of 3IATLAS's closest approach to the Sun, the tension within the scientific community is palpable. The object has already defied expectations in countless ways, and the coming days will determine whether we are witnessing the death of a typical comet or the unfolding of a truly extraordinary event. Will the object fragment as it gets closer to the Sun, or will it survive, leaving us with more questions than answers? This question is crucial, and the outcome will either confirm 3IATLAS's status as an odd but natural comet or push us toward considering more radical possibilities, including the idea that it is an artificial object. The most significant test will come on October 29th when 3IATLAS reaches its perihelion, the point in its orbit where it will be closest to the Sun. Comets that venture this close typically experience immense thermal stress. As the Sun's heat penetrates the comet's icy nucleus, the internal pressure causes the structure to break apart, creating the characteristic dust and gas trail that forms the comet's tail. In fact, this process is so predictable that scientists often use the fragmentation of comets to better understand their structure and composition. If 3IATLAS behaves like a typical comet, it will fragment, its icy nucleus will vaporize, and the outgassing will intensify. The anomalies in its behavior, such as its anti-tail, the ejection of nickel without iron, and the strange chemical composition, would likely be attributed to rare, albeit natural, phenomena. The scientific community could then offer explanations for these irregularities, chalking them up to unknown but explainable cometary behaviors. However, if 3IATLAS survives perihelion intact, that will be a game changer. The idea of a comet surviving so close to the Sun without fragmenting challenges everything we know about comet behavior. It implies that 3IATLAS could be made of material far more resistant to thermal stress than any known comet. Alternatively, it could suggest that the object is not a natural body at all, but a piece of technology, engineered to withstand the extreme conditions of space. This is the critical juncture at which the scientific community will have to decide. Are we looking at an extraordinary comet, or is 3IATLAS something entirely different? If the object survives and continues on its trajectory, it will force us to reconsider our understanding of the forces at play in space. The implications of this scenario are profound, as it would suggest that 3IATLAS is either an incredibly dense natural object or an artificial one. Either option would rewrite much of what we know about celestial bodies. At that point, the possibility that 3IATLAS is a probe or a spacecraft sent by an extraterrestrial civilization will become more than a fringe theory. It would be a serious hypothesis. The trajectory of 3IATLAS has also sparked further interest. When the object entered the solar system, its path was highly unusual. Most interstellar objects, as they approach the Sun, are pulled in by its gravity in a predictable way. 3IATLAS, however, came in at an angle and speed that was statistically improbable. Scientists have calculated that the chance of it following this exact path naturally is only about 0.2%. This is a tiny probability, one that, in many cases, would be dismissed as simply a fluke. But when combined with the other anomalies surrounding the object, it becomes hard to ignore the possibility that 3I-ATLAS is not simply a random wanderer from another star system. Its trajectory suggests a level of precision that would make sense if it were intentionally navigated, if it were part of a larger mission. In this context, the potential for intelligent design, whether extraterrestrial or otherwise, becomes more plausible. The idea that 3I-ATLAS is an interstellar probe designed for a specific mission fits perfectly with its trajectory. If this is the case, the object could have been sent intentionally to explore our solar system, perhaps even to gather data on Earth and its surrounding planets. Its ability to avoid detection for so long as it passed Venus, Jupiter, and Mars hints that it might have some form of cloaking or stealth technology, or at the very least, an understanding of how to navigate space undetected by our current observational tools. Furthermore, the close encounter with the Sun itself could be a deliberate maneuver. Gravitational assists, where an object uses the gravitational pull of a planet or a star to change its speed and direction, are a well-known technique for space probes. 3I-ATLAS's trajectory suggests it could be using this technique to adjust its course, making it more likely that its path is the result of intelligent navigation rather than random chance. The timing of this maneuver is no coincidence. It's as if the object is taking advantage of the Sun's gravitational field to adjust its course and gather data, much like a probe would. But this still leaves the question of why it would be here at all. If 3I-ATLAS is a probe, why has it traveled across the galaxy, perhaps for billions of years, only to pass through our solar system now? The answer could lie in the age of the object. As mentioned earlier, 3I-ATLAS is older than our solar system, suggesting that it could be a relic from a much older civilization. If this is the case, then the probe might have been sent out at a time when this civilization was still active, only to remain dormant for eons as it journeyed through the galaxy. Perhaps its mission is still ongoing, its primary objective to observe, collect data, and send it back to its creators, or perhaps to gather information that could be of use to those who sent it. What happens next will be key. As 3I-ATLAS moves closer to the Sun, its behavior will be scrutinized like never before. If it behaves in the expected way for a comet, the scientific community will likely breathe a collective sigh of relief and offer explanations for its strange properties, relegating it to the category of a bizarre but natural object. However, if it survives perihelion intact, if its outgassing and trajectory continue to defy all expectations, then we may be on the brink of something much larger. A discovery that forces us to completely rethink our understanding of the universe. In the coming days, all the world's leading telescopes and observatories will be trained on 3I-ATLAS. The data they collect will either confirm our suspicions that this is a comet or push us to the unsettling realization that we may be witnessing the first confirmed evidence of extraterrestrial technology. Whatever the case, this is a moment in human history that will shape the future of space exploration and our understanding of our place in the cosmos. We are witnessing an event that could either reinforce our current models of the universe or upend them entirely. The waiting game is almost over, and in the coming days, the scientific community will have its answer. Whether we're about to confirm the existence of life beyond Earth, or simply add another strange comet to the catalog, one thing is certain. 3IATLAS has already changed the way we look at the universe, and regardless of the outcome, it has set the stage for even more profound questions about the nature of life, intelligence, and the cosmos itself. The next few weeks will be critical as we move closer to the moment when 3IATLAS reaches perihelion, the closest point in its orbit to the Sun. As this mysterious object speeds through the solar system, every bit of data is closely analyzed, and the questions continue to mount. The anticipation is building not just among scientists, but among the public as well. The debate over whether 3IATLAS is a comet, a probe, or something else entirely is reaching its climax. But in the background of all the scientific curiosity, one fact remains clear. 3IATLAS is pushing the boundaries of what we know, forcing us to reconsider our understanding of the universe. One of the most intriguing aspects of 3IATLAS's journey is the possibility that it has been intentionally designed to travel through the galaxy, either by an advanced civilization or for an unknown purpose. The sheer complexity of its trajectory, the unexpected velocity anomalies, its precise alignment with the Sun for a gravitational assist, and its ability to avoid detection until very recently, all suggest that this object could be far more than a random interstellar visitor. Could it be an interstellar probe? If so, why is it here, and who sent it? As the object approaches the Sun, the question of its origins becomes even more pressing. If 3IATLAS survives its closest approach without fragmenting, it will provide even more evidence that it is not a typical comet. Comets typically break apart when they get this close to the Sun, their icy nuclei, vaporizing under the intense heat and pressure. If 3IATLAS doesn't fragment, then it will force us to seriously consider that this is not a comet, but something else, something engineered perhaps to endure the harsh conditions of space travel. Surviving perihelion would suggest that 3IATLAS is far more robust than any comet we've ever studied. The object could be made of metal or some other exceptionally strong material. The idea that it could be artificial, either an ancient probe or a piece of technology, would become increasingly difficult to dismiss. If it remains intact after passing so close to the Sun, it might also suggest that it's not simply a relic of a forgotten civilization, but rather an active spacecraft, still performing its intended function after traveling across vast stretches of space for potentially billions of years. Scientists are waiting with bated breath, but the next few days will not just be about surviving perihelion. The real question is whether 3IATLAS will reveal more unexpected behaviors that suggest it is actively maneuvering or responding to its environment. So far, the object's behavior, such as its directional outgassing, the presence of industrial chemicals like nickel tetracarbonyl, and its high-velocity anomalies, has been far from ordinary. These are not the typical characteristics of a comet, which only becomes active when approaching the Sun and is usually driven by relatively simple physical processes. If the object continues to behave in ways that don't match known cometary behavior, it will only strengthen the case that 3IATLAS is something far more sophisticated. If 3IATLAS continues to shed material at an accelerated rate, or if its trajectory continues to show anomalies that can't be explained by gravitational forces, the debate will move beyond the natural versus artificial dichotomy. It will no longer be a question of whether this is a comet or a probe. It will be a question of what kind of technology this object might represent, and whether it was designed to be as resilient and active as it has proven to be. What's also significant about the approach of 3IATLAS is the potential for future exploration. If this object survives perihelion and continues on its course, we might consider sending a spacecraft to study it more closely. After all, if 3IATLAS is indeed a probe or some sort of artificial object, it could hold the key to understanding an entirely new realm of technology, one that could change our approach to space exploration. But we are running out of time. The window for study in 3IATLAS in its current form is rapidly closing. After perihelion, it will be moving away from the Sun, and soon it will be too far and too faint to study with current instruments. The question of what to do next after the object leaves the inner solar system is complicated. Some researchers have suggested the possibility of a fast response mission, one that could be launched soon to catch up with 3IATLAS after it leaves the solar system. While such a mission would be technically feasible, it would also require an enormous amount of resources, collaboration, and a level of urgency that space agencies are typically not accustomed to. The technology for such a mission exists. Ion propulsion systems and deep space probes could be used to intercept objects at high velocities, but political and funding considerations could delay any potential mission for years. By that time, 3IATLAS could be too far away, and any valuable data would be lost. This is one of the critical issues facing the study of interstellar objects. Historically, we've had little time to observe and study these visitors before they leave our solar system. With 3IATLAS, we have had months of advance warning, but the moment of closest approach is still limited. There is an urgent need for better technology, more responsive space missions, and a greater willingness to take bold action when such extraordinary opportunities arise. 3IATLAS may be a catalyst for a new approach to studying interstellar objects, one that moves beyond the slow, methodical pace of traditional space exploration to something more immediate and more adaptive. In the meantime, astronomers and scientists are continuing to collect as much data as possible. The observations made during this critical time will likely be analyzed for years to come. Even after the object has moved on from our solar system, the data we collect now could have profound implications for our understanding of space, celestial mechanics, and even the possibility of extraterrestrial intelligence. Whatever happens in the coming weeks, 3IATLAS has already reshaped the way we think about interstellar objects and their potential for revealing secrets about our universe. At this moment, the scientific community is at a crossroads. The next few days will determine whether 3IATLAS is simply an extraordinary comet or something far more remarkable. Will it behave like a comet, or will it reveal itself as something far more alien to our understanding of the cosmos? The answer may change everything, not just in terms of science, but also in how humanity perceives its place in the vast, unknown universe. This is the moment that could redefine our understanding of space exploration and interstellar travel. It may not just be a comet that we are studying, it could be a message, a probe, or a relic from an ancient civilization. a piece of the galaxy that has traveled across unimaginable distances to visit us. Whatever the case, we are witnessing an unprecedented event, one that has the potential to change everything we know about the universe and our place within it. As we near the critical moment in the journey of 3IATLAS, the questions continue to mount, each one pushing the limits of our understanding of the cosmos. What started as an enigmatic, out-of-place comet has evolved into a puzzle with more pieces than we can currently fit into our existing frameworks of science. With every observation, the object's behavior becomes harder to explain through conventional models. Now, with only days before its closest approach to the Sun, astronomers are closely monitoring the situation, wondering if we will witness the expected breakup of the comet, or if, instead, we will be faced with an extraordinary discovery that reshapes our view of the universe. The event that will unfold when 3IATLAS reaches perihelion could be a scientific milestone of unprecedented importance. Traditionally, comets fragment as they approach the Sun, their icy nuclei rapidly vaporizing under the extreme heat. But if 3IATLAS doesn't fragment, if its structure remains intact, even under such extreme conditions, it will force us to reconsider what we know about cometary formation, structure, and resilience. It might not just be a comet, it could be something much more extraordinary. Could this be the moment when humanity realizes that we're not alone in the universe, and that the galaxy may be full of artifacts far more advanced than we ever imagined? In the weeks leading up to perihelion, the object's behavior will provide key clues. If it survives the intense heat and continues its trajectory unharmed, it would be unlike anything we've seen before in the solar system. A comet that endures such extreme conditions would either need to be made of exceptionally robust material or be something that wasn't naturally formed in the first place. The idea of it being an artificial object, perhaps an ancient probe sent to study our solar system, becomes more plausible with each passing day. For now, scientists are preparing for the possibility that 3IATLAS could reveal itself as an anomaly in the broader cosmic landscape. Its behavior thus far, its unexpected trajectory, its anti-tail, its strange chemical composition, has defied every known law of comet physics. And as we approach the moment of truth, the object's ability to survive perihelion will be the ultimate test of its nature. If it passes this test, it will force the scientific community to confront the possibility that interstellar travel, at least in some form, may be far more common and far more advanced than we previously thought. But survival of perihelion is just one part of the puzzle. The trajectory of 3IATLAS has been nothing short of extraordinary. When it first entered the solar system, the object's orbit was deemed highly unlikely by traditional models of interstellar object behavior. The object's speed and the way it navigated the inner solar system appeared to have a calculated, purposeful quality, something we would expect from an object sent intentionally through space. These velocity anomalies, though subtle, are yet another piece of evidence pointing toward the idea that this object is not a random cosmic visitor, but possibly something designed for a specific purpose. If the object's trajectory is indeed the result of purposeful navigation that suggests intelligence behind its movement, perhaps 3IATLAS is not just an object traveling through space on a random course. Maybe it was deliberately placed on its trajectory, guided by the gravitational forces of stars, planets, and even comets themselves, or by a more sophisticated system altogether. The precise movement of 3IATLAS as it navigated past Venus, Jupiter, and Mars undetected, until it came within range of our telescopes, suggests it has some form of stealth technology designed to avoid detection. The notion of an ancient interstellar probe moving through our solar system unnoticed takes on an eerie, almost sci-fi quality. Could it be that we are not looking at a comet, but an ancient, autonomous object sent out eons ago by an extraterrestrial civilization? Some scientists have even proposed the idea that 3IATLAS might have been sent deliberately to study our sun and planets. If this is true, then the perihelion pass on October 29th will be a moment of observation, a chance for the object to gather critical data about our solar system. After all, a probe designed to travel through space and collect information would need to pass through our system at a key moment, utilizing the sun's gravity to adjust its course and maximize its efficiency. The sun's gravitational field could serve as a tool for the probe, increasing its velocity and altering its trajectory, allowing it to reach its next destination after its studies are complete. This type of navigation, using the sun's gravity for a gravitational assist, would not be uncommon for advanced spacefaring civilizations. Yet, despite the compelling evidence suggesting artificial origins, we must also acknowledge the possibility that 3IATLAS is a natural object, a comet that happens to possess some unusual characteristics. Perhaps it formed in an environment that is entirely different from our own solar system, with conditions that led to its unique composition. Perhaps it is a rogue comet, formed around a distant star and launched out into the interstellar void. Even if it is a natural object, 3IATLAS challenges our understanding of cometary behavior, outgassing processes, and the chemical makeup of these cosmic wanderers. But the more we learn about 3IATLAS, the more its behavior seems to suggest an origin far beyond what we expect from nature. The anti-tail, its gas and dust trail pointing directly toward the sun, remains one of the most striking features of this object. The tail of a typical comet is always blown away from the sun by solar wind, but 3IATLAS defies that expectation. The presence of this anti-tail, combined with the object's peculiar chemical composition, including the ejection of nickel without iron, strongly suggests that 3IATLAS is not merely a comet. If it is artificial, then the idea that it was intentionally constructed, possibly for an interstellar journey, becomes more plausible with every new observation. One of the most critical aspects of 3IATLAS's behavior is the water vapor emission. The Swift telescope detected a staggering 40 kilograms of water vapor being released every second from the object's surface, even though 3IATLAS was located at about 3 astronomical units, AU, from the Sun, roughly the distance between Mars and Jupiter. In a typical comet, outgassing doesn't begin until it gets much closer to the Sun, inside 2 AU or 1.5 AU. At this distance, the Sun's heat should be insufficient to vaporize the ice, yet 3IATLAS is spewing water as though it were much closer to the Sun. This anomaly only adds weight to the hypothesis that something other than natural forces might be driving the object's activity. It's this strange combination of anomalies, the trajectory, the outgassing, the anti-tail, and the unusual chemical signature, that leaves scientists grappling for an explanation. Could these irregularities be explained by the nature of 3IATLAS itself? Or do they point to something that fundamentally challenges our understanding of cometary dynamics and even the possibility of intelligent design? The truth may lie somewhere in between. 3IATLAS could be a natural object exhibiting rare, unusual behaviors, or it could be a technological artifact, the remnants of an ancient interstellar mission. As the object nears perihelion, we will soon find out what lies beyond this cosmic enigma. The answers we uncover in the coming days will not only reshape our understanding of 3IATLAS, but they will also have profound implications for the future of space exploration, our search for extraterrestrial life, and the very nature of intelligence in the universe. One thing is certain. 3IATLAS is already forcing us to expand the boundaries of what we know and what we think we know about the cosmos. As 3IATLAS approaches its perihelion, the most pivotal moment in this object's journey, the scientific community stands at the edge of a potential breakthrough or a reaffirmation of our current understanding of the universe. In just a few days, we will see whether this mysterious object behaves like a comet, shedding its material and fracturing under the intense heat of the sun, or whether it defies expectations and continues on its course with unprecedented resilience. The outcome will shape not only our understanding of this object, but also the larger questions of interstellar exploration, the existence of intelligent life beyond Earth, and the limits of human knowledge in the cosmos. If 3IATLAS survives perihelion and remains intact, it will force scientists to reconsider the definitions of comets, interstellar objects, and potentially even artificial constructs. In the past, we have only been able to observe such objects in a limited context, often for too short a time to fully understand their nature. With 3IATLAS, we have months of data and the rare opportunity to study an interstellar object as it passes through our solar system. It may seem like a small opportunity in the vastness of space, but in terms of astronomical discovery, it's a momentous event that could reveal far more than we've yet imagined. The theories surrounding 3IATLAS continue to proliferate. Some scientists argue that the object is simply a bizarre comet, one that formed under unusual conditions in its original star system, which could explain its high speed, unusual shape, and odd outgassing behavior. This theory is supported by the object's overall composition, which, though strange, doesn't necessarily demand an artificial origin. It's possible that 3IATLAS is a comet from an ancient solar system, one that formed in a more volatile environment, which led to its unusual carbon dioxide to water ratio and other anomalous features. On the other hand, many researchers, including Professor Avi Low, are pushing the idea that the object's behavior is too anomalous to fit within natural models. The anti-tail, the nickel without iron, and the strange industrial compound found on the object, nickel tetracarbonyl, all point to something that could be artificially designed. If 3IATLAS were a spacecraft or probe, its cylindrical shape, along with the way it has maneuvered through the solar system, would make sense as part of an intentional journey through space. The idea that it has been deliberately navigating our solar system and has avoided detection until now suggests the possibility that it's more than just a passive visitor. It could be an active probe from an ancient or even ongoing extraterrestrial mission. As we await the object's closest approach to the Sun, scientists are particularly interested in the behavior of 3IATLAS's outgassing. We've seen massive water vapor emissions coming from the object, far more than we would expect from a comet, at its distance from the Sun. This phenomenon alone has pushed researchers to reconsider what drives cometary behavior. In typical comets, outgassing begins only once they are close enough to the Sun for its radiation to heat the object's surface and release the volatile compounds within. But 3I-ATLAS is showing signs of active outgassing even at distances farther out in the solar system, suggesting that something else is providing the necessary energy. The outgassing could be powered by internal heat, perhaps something akin to radioactive decay, or it could be a sign of an engineered process designed to provide thrust or cooling for an artificial object. The large amount of water vapor being emitted by 3I-ATLAS is particularly perplexing because at 3 AU from the Sun, the solar radiation is too weak to explain the levels of activity observed. In comets, this behavior is usually linked to the Sun's heat, but in the case of 3I-ATLAS, this is not the case. The object is emitting far more water than we would expect for its current distance from the Sun. This unexplained outgassing could indicate that there's an additional source of heat or energy, which leads many to consider the possibility that 3I-ATLAS is not a typical comet, but something designed to remain active and resilient over long periods of time, perhaps even for billions of years. Then there's the question of what happens after 3I-ATLAS passes perihelion. Once it has completed its closest approach to the Sun and begins its journey back into deep space, the object will likely become increasingly difficult to study. The closer it gets to the Sun, the harder it will be for ground-based telescopes to get clear observations, due to the Sun's glare. Space-based observatories will still be able to track it, but they will also be limited by their observational angles and the object's increasing distance. The opportunity to study 3I-ATLAS in detail will become fleeting, so the data gathered in the next few weeks will be vital for scientists to either confirm or disprove their theories. While some researchers hope that 3I-ATLAS's passage will provide definitive answers, there's a lingering feeling that we may be on the verge of something far more complex. Perhaps the object will not fragment, and we will be left with more questions than answers. It could raise new possibilities for interstellar exploration, suggesting that the universe is full of objects far more complex than we currently recognize. It might even open the door to new ways of thinking about life beyond Earth, and what form that life might take. Regardless of whether 3I-ATLAS turns out to be a comet, an artificial object, or something in between, the fact that we are witnessing this object's journey at all is a significant moment in scientific history. In the past, we have been forced to imagine the mysteries of space through speculation. But with 3I-ATLAS, we are witnessing firsthand an object that challenges everything we know about the cosmos. Whether the object survives perihelion or not, whether it behaves in ways we expect or completely defies our models, it is a reminder of how much we still have to learn about the universe. The data from 3I-ATLAS, whatever it ultimately reveals, will become a cornerstone for future research into interstellar objects. We are still in the early stages of studying these visitors from other star systems, and each one teaches us more about the vastness of space and the potential for discovery beyond our own solar system. As we learn more, we may find that the boundaries of our understanding are much broader than we ever imagined. For now, all we can do is wait. The critical moment is fast approaching, and the final answer to the mystery of 3I-ATLAS will soon be upon us. Will it fragment like any normal comet, or will it remain intact, revealing itself as something far more extraordinary? Whatever the outcome, one thing is certain. This interstellar visitor has already sparked a revolution in our thinking. It has forced us to question the assumptions we have made about space, comets, and the possibility of intelligent life elsewhere in the universe. The real journey is just beginning, and the possibilities are endless.